Welcome. We are dealing with a new topic called the Arithmetic series. And for us to appreciate this topic, we have to appreciate this guy. Well, you are looking at him and he's looking at you. And you are asking, who is the name? His name is Carl Friedrich. I hope I spelled that correctly. Friedrich Gauss. All right. He was born on the 30th of April, and that was in 1777, and that was in Germany. Okay. He is regarded as the most influential mathematician and physicist, and he made the following contributions. He proved the fundamental theorem of algebra. All right, and this is going to be relevant for those of you who will be doing third year abstract maths. So if you're doing abstract math in third year, you know what I'm talking about. He is believed to have discovered also non-Euclidean geometry. Okay, this is the geometry that Einstein was using for the most part in his theory of relativity. And of course, for those of you who are doing physics, he is responsible for Gauss's law of magnetism. So he's quite an important figure. But the reason we are interested in this guy is what happened when he was about 8 or 9 years old. We are told that when he was 8 or 9 years old, their teacher told them that they must add the numbers 1 to 100. Now, you must note that at the time they didn't have calculators, they didn't have any of the fancy material that we have today. So it was difficult to add 1 plus 2 plus 3 plus 4 all the way to 100. All right. So Gauss came with an approach that is relevant to us, and we are going to discuss that approach. We will say S will stand for sum. Okay. And he said, okay, let me try to add 1 plus 2 plus 3 plus 4. Right, plus 97 plus 98 plus 99 plus 100, and that is 100 terms. All right, 100 terms. And he said, okay, what will happen if I wrote this sum in reverse? Nothing changes, because here we are talking about a commutative property. So nothing changes. A plus B is the same as B plus A. It will give us the same answer. So I can write this as 100 plus 99 plus 98 plus 97 ... plus 4 plus 3 plus 2 plus 1. And it would still be 100 terms. Okay. Then he said, what happens if I add these terms? Guys, if you add these terms, the number won't change, because it will be 100 plus 1, which will be 101. So now you are having one term. So the number of terms won't change. All right. So if you add S plus S, you get 2S. All right. 1 plus 100 will give us 101. 2 plus 99 will give us 101. 3 plus 98 will give us 101. 4 plus 97 will give us 101. ... 97 plus 4 will give us 101. 98 plus 3 will give us 101. 92 plus 99 plus 2 will give us 101, and 100 plus 1 will give us 101, and we still having 100 terms. Right. But then he realized that we can summarize addition with multiplication. And let me give you an example. If I have 1 plus 1 plus 1 plus 1 plus 1, how many times are here? 1, 2, 3, 4, 5. Okay, so if I wanted to summarize this, I can write this as 1 times 5. 5 being what? Being the number of terms. Okay, now because 101 is repeating itself 100 times, we can write this as 100. That is the number of terms that are there, multiplied by the repetition, which is 101. All right, so this is 2s equals to 100, but 101 is the same as 1 plus 100. Okay, divide that by 2, so this is 2s equals to 50 times 1 plus 100. And then of course we can I forgot to remove the 2. Of course here this multiplied by that is 50, and 1 times 5 is 5. How many zeros are there? There are 3 zeros, so this is 5050. All right, so that is the method that is going to be relevant when we get to the arithmetic series. All right, in essence, if you check this here, this is actually our first term, and this is actually our last term. All right, let me just remove this. This is our first term, this is our last term, and this is actually our number of terms. So from this is a formula that we are going to be using. If I know the number of terms and I add the first and the last term multiplied by the number of terms, divide them by 2, I can get the sum of this entire series, or any series for that matter, if I know the first and the last term. Okay, let's try to apply it differently. Let's say I'm giving you 2, 4, 6, 8, 10 all the way to 100. 2, 4, 6, 8, 10 all the way to 100. How many terms are there, guys? Well, you are right, there are 50 terms, because you are skipping a term. Okay, there are 50 terms. So using this approach, it says if I know how many terms are there, if I know that there are 50 terms, so this will be 50 terms. What is the first term, guys? The first term is 2. What is the last term? The last term is 100, and you divide that by 2, you should get your answer. All right. This here is 25. 2 plus 100, and 25 is 50, and of course this is 2500, and the answer here should be 2550. Okay, guys, please, you can use a calculator. You don't have to do what I did here. This is me imagining how Gauss would have solved it without a calculator, which you also learned in grade 8. All right, so this is the formula. If you know the number of terms, if you know the first term, and you know the last term, add the first and the last term, multiply it by the number of terms, then divide by 2, you should get the sum of any sequence, saving you time and hopefully money in the process. We want to really continue with the logic that Gauss has introduced us to, and we want to try to generalize the logic. All right, so we will say consider the arithmetic sequence. Okay, and I will give you, you know that it's always like, it's always like this: T1, okay, then followed by T1 plus D, okay, T1 plus 2D. All right, this is the general form that I believe we introduced you to. All right, and then I can say dot dot dot, and I will start with the first term, with the last term rather. And if you are working backwards, let's say your last term was 100 and your numbers was 1, 2, 3, 4, you can see that the common difference is found by adding. Okay, for you to get the next numbers, you would add 1. But if I want to get the numbers before 100, you understand that I must subtract 1. Okay, so here what we will do is that we will subtract the common difference so that we get the term before the last term, and then of course we will again subtract the common difference twice so that we get the second term before the last term. And that is the logic that we are using to be able to do that. Now suppose this is our series. If we are using the Gauss's approach, we would say Sn, the sum of the first term, is equals to T1 plus T1 plus T1 plus D plus T1 plus 2D plus ... and that is Tn minus 2D, and that is plus Tn minus D plus Tn. Okay, now Gauss said he wants to write this thing differently, so inversely, so we use his approach here. We will write this as Tn, we will write this as Tn minus D, we will write this as Tn minus 2D, and ... we will write this as T1 plus 2D, we will write this as T1 plus D, and we will write this as T1. Then Gauss said we should add these things, so Sn plus Sn, it is 2Sn, right? And then now check T1 plus Tn, it is T1 plus Tn. Notice what happens here, the D and the D cancels out so that you are left with T1 plus Tn. Okay, and notice the 2D and the 2D cancels out so that you have T1 plus Tn. All right, blah, that ... this and this cancels out so that you have T1 plus Tn again, and then this and this will cancel out so that you have T1 plus Tn, and again we have T1 plus Tn. All right, and we showed you in the example that you have to write this in summary format, and the way we summarize this, because we know that there are n terms, and we know that there are n terms. In order for us to summarize that, we know that we use multiplication, so we'll say 2Sn equals to n multiplied by T1 plus Tn, right? And at this point we divide both sides by 2 so that we have n times T1 plus Tn all over 2. And if you want to write it much nicer, it can be Sn equals to n over 2 T1 plus Tn. Well, T1 is the first term, so I will say let A be equals to T1, and I will say let L be equals to Tn. L stands for the last term, therefore our equation is given by n times A plus L over 2, which is the same as Sn equals to n over 2 A plus L. So that is important for you to note. This is our first equation that we would be working with. It says that when you're given the first and the last term, add the first and the last term multiplied by the number of terms in the series, then divide by 2. But from this we can derive something else. Well, since we have Sn being equals to n times A plus L divided by 2, Sn is the same as n over 2 times, and let me just write it this way. It's the same as n over 2, and we know that A is just T1, and we know that L is just Tn. Okay, so this is the same as n over 2. Well, from arithmetic sequences, you know that the first term is equals to A, and then you know that Tn equals to A n minus 1 D. So this is A plus A n minus 1 D. Okay, so that is n over 2. Notice what we have here. A plus A gives us 2A, and this is plus n minus 1D. Alright guys, we continue. Now you want to look at examples. Remember what you have learned in the previous video, that these are the formulas that we are going to be using to solve series that are arithmetic in their nature or behavior. Sn equals to n over 2a plus l, and then you'll use Sn equals to n over 2a n minus 1d. Those are the two formulas that we're going to be using. Let us look at the first example, and this is example 1. We will say determine the sum of the first 20 terms of the series 3 plus 7 plus 11 plus 15 ... Solution. All right, now you have to first ascertain what type of series are you dealing with here. If you notice, for us to get from here to here, we are dealing with we must add 4. To get from here to here, we must add 4, meaning this series has a common difference, because 7 minus 3 is 4, 11 minus 7 is 4. So it means that we are dealing with a series that is arithmetic. Okay, so we can then apply the formulas of the arithmetic. Let us state what we are given. Well, we are told that the first term here is 3. We are told that the value of n is 20 terms. All right, but now we can see ... says that this series continues until term number 20. We are dealing with finite things here, until term number 20. However, we don't know what term number 20 is, neither do we have time to find what term number 20 is. So instead of us using this, because we don't know what is L, you will use this one. All right, so Sn equals to n over 2a n minus 1d. All right, so how many terms are here? There are 20 terms. Wherever I see n, I put 20. What is my first term? My first term is 3. How many terms are there, guys? There are 20 terms minus 1. And of course, the common difference, we have just established that the common difference is 4. That is very important. So S20 equals to 10, and this is 6 plus 19 times 4. So S20 equals to 10, and this is 6, and then 19 times 4. Let me just use a calculator for that. I am lazy to think or type. That is 19 times 4, so that is 76. Okay, so S20 equals to, and then let's check here, 76 plus 6, this is 10 multiplied by 82, and of course S20 is 820. Okay, we can take a second example. Example 2. We will say calculate the sum of the following finite series: 3 plus 5 plus 7 plus 11. All right, in this situation, you can use either formulas. You can use either of the formulas, guys. You can use this formula. If you were gonna use this formula in this scenario, you were first gonna find what is Tn. Then, okay, after finding out your general formula, then substitute T20. Then T20 will be your last term, and you would apply this formula. It's just that it's a long drive. Okay, so let us look at this one here. Well, what are we given here, guys? And of course, you can see that this, for us to get from here to here, we are adding by 2. For us to get from here to here, we are adding by 2. So we are given that our first term is 3. Our common difference is 2, and this time we are given the last term. What are we not given? we are not given the value of n, and we can see from all the formulas that n is crucial, so we have to first find n. So the only way to find n is by finding first what is the general formula for this sequence. Okay, so I will say Tn equals to a n minus 1d. Well, let us see. For me to know how many terms are here, I have to know what is the last term, and the last term is given. The last term is 111. The first term is 3. This is n minus 1, and of course the common difference is 2. All right, from here you can say this is 111 minus 3. This is 2n minus 2. All right, I hope I'm not being too fast for you. All right, I hope I am not too fast for you. All right, 111 minus 3, by now you know that is 108, and this is 2n minus 2. Therefore this is 110, because when you apply the additive inverse, 108 plus 2 is 110, which equals to 2n. Therefore divide both sides by 2. The value of n is 55. So therefore we have concluded that there are 55 terms in that sequence. The relevant sequence to use in this case is this one, because you know the first and the last term. So we will say Sn equals to n over 2 a plus l. And then this is Sn. How many terms are here? There are 55. So wherever I see n, I put 55. What is my first term? My first term is 3. What is my last term? My last term is 111. Yeah, it's 111. It's 111. Okay. And then that is just 55 divided by 2, which is 114. And of course, that is 3,135. All right, so it's always important, guys, that you look at the situation that you are given. All right, let's go to example 3. Example 3, we will say the sum of the series 5 plus 3 plus 1 is negative 216, and we say to you, determine the number of terms in the series. All right, look at that. Now guys, I want you to look at the cases that we dealt with here. Here we were not given the last term, so we used this formula. Okay, here we didn't know the number of terms, so we first found the general formula, and then that led us to the number of terms, and then we use that formula. But I want you to look at this now. This is a case where you are given Sn. They tell you that Sn is 216. Okay, so we are given Sn. Let us read the question. The sum of the series. Now let us establish what type of series is this. For us to go from here to here, we subtracted by minus 2. Okay, for us to go from here to here, we subtracted by minus 2. So already we know that the common difference is minus 2. We know that the first term is 5. They say to you, determine the number of terms. So we must find out how many terms are there in the sequence. You cannot use this. You cannot use this, because you don't know how many terms are there in the sequence. So your only option is to use this, because it works when you don't know how many terms do you have in the sequence. Sn equals to n over 2, 2a, n minus 1d. Now, we are looking for n. Do we know what is the sum? Yes, the sum is negative 216. Do we know how many terms are there? No, we don't. So we just write n as it is. Do we know what is the first term? Yes, the first term is 5. Do we know what is n? No. Do we know what is a common difference? Yes, we know what is a common difference. Okay, so that is now negative 216 n over 2. And this is 10 minus 2n plus 2. This is negative 216 n over 2. And of course, here we are dealing with 12 minus 2n. From this point, we can multiply by 2 over 1. We can multiply by 2 over 1. All right, so that you will notice that if you multiply this by 2 over 1, we will get negative 432, and here we will have n. All right, so this is 12 minus 2n. All right, so now we can then continue with that and say, okay, this is negative 432. When you multiply that and that, you get 12n. When you multiply that and that, you get negative 2n squared. All right, well, we can bring everything to the other side just for us to have n to be positive. So this is 2n squared minus 12n minus 432 equals to 0. Additive inverse. We took everything that was this side and we brought it that side. All right, and then we can just simplify this by dividing all sides by 2, so that we have n squared minus 6n minus 216 equals to 0. We can factorize this. This is n and n, minus 18 and plus 12. Therefore, n equals to 18 or n equals to negative 12. But n cannot be negative. Therefore, how many terms are here? There are. Therefore, n equals to 18. Therefore, there are 18 terms in the series, or you can say 18 terms add up to negative 216. I hope you understood.